All right, so we're going to call this Solving Rational Equations Part 2. Same target as last class. Don't need to rewrite it. So if you were not here last class, we've already done 4 examples of rational equations. So we are already somewhat familiar with this. Okay, we did not have an assignment. We will today. We'll have practice problems and then we'll have a quiz next class. Okay, oh wait. This should be, we did 4 examples last time. This should be example 5. We're going to solve x squared minus 20 divided by x squared minus 7x plus 12 equals 3 divided by x minus 3 plus 5 divided by x minus 4. These are called rational equations. Rational equations. When you see an equation that has an equal sign and fractions in it with variables, those are called rational equations. So the first thing you want to do, and there's a lot to it, right? You have to be very particular in your handwriting. Don't try to cram it all in one little space because you're going to make mistakes. First thing you do is we're going to factor any denominator if possible. If everything's already factored, cool. If you have a numerator that can be factored, we don't care, okay? Denominators is what we care about. So let's just real quick, x minus 4, can that be factored? No, it's linear, there's no GCF. X minus 3, can that be factored? Linear, there's no GCF. How about x squared minus 7x plus 12? Probably, right? It's a quadratic, we can probably factor it. So let's do that over here on the side. If you still don't know how to factor, that makes solving these very difficult. You gotta learn. So in my quadratic, x squared minus 7x plus 12, is there a GCF? Do they all have an x? No. No GCF, right? What is a equal to? What is b equal to? -7. What's c equal to? 12. So our t-chart, we need 2 numbers that multiply together to give us a times c. In this case, a times c is positive 12. And then add to give you b, which is -7. -3 and -4, let's see. And it's got to work on both sides, right? -3 times -4 is positive 12. Works on the left. Well, what's -3 plus -4? -7. So is that quadratic factorable? Yeah. So my parentheses, first term, the variable being used is x. Second term comes from the t-chart. The numbers that worked on both sides, not the 12 and -7. Those are not the numbers that worked on both sides, right? It was the -3 and the -4. Divide and slide if necessary. Is this necessary to divide and slide? No, because a is 1, right? So I'm going to rewrite my problem. I'm going to rewrite this denominator in factored form. And remember, I'm going to space everything out because I'm going to have to come back and multiply by the LCD, which I'll determine in a minute. But right now I'm going to rewrite it, giving myself some space. So x squared minus 20 divided by, I'm going to put the factored form here, which we said was x minus 3 times x minus 4. Then bring down that equal sign. I'm going to give myself some space before the next term. Then bring down the plus sign and give myself some space for that last term. Stop me if you have a question. I don't understand. Where did you get this from? Why did you do that? Stop me at that point so I can answer you. All right, now what we want to do, we don't want those fractions anymore. We want them to go away. We want to clear the fractions. So we have to figure out what's the least common denominator. And we'll multiply each term. Each one of these fractions is considered a term. Each term by the least common denominator. Somebody give me one factor of the LCD. Just x. Is there an x by itself all alone? X minus 3. It's a binomial, that whole thing, right? Give me another one. X minus 4. Do I have another one? No, I need one of each factor. The only time you would put two factors, say in my first fraction, say it was x minus 3 and x minus 3. 2 in one fraction. Then I would have to say x minus 3 2 times. Otherwise, if I just use it once, only one of the x minus 3s will equal. Okay? Otherwise, in each fraction, if there's just one of the factors, then that's good. So what I'm going to do is I'm going to multiply every term by x minus 3 times x minus 4. Remember, when you do that, when you multiply fractions, you do numerator times numerator, denominator times denominator, right? So I'm kind of making like giant fractions. And the whole purpose is I want to cancel out the denominators. I want them to turn into a 1. So my first fraction, does anything cancel? Right, x minus 3's cancel and x minus 4's cancel. What about in the second fraction? X minus 3's cancel. What about in the last one? Just x minus 4. Now, all of our denominators were canceled out. They all turned into a 1. We know 1's the only thing in the denominator. We don't need to write that, right? So let's go to each fraction and write what's left. Anything that's left, we'll multiply. Any factors that are left, we'll multiply them together. But let me just write them down first. So in the first fraction, the only thing that was left was x squared minus 20. Make sure you bring your equal signs down and your pluses or minus signs down when you're supposed to. So next we had an equal sign. Next, the only factors that are left are the x minus 4 and the 3. So that 3 is just a monomial, right? I like to put that first when I have a monomial before a binomial. Next, I have a plus sign. And then in the last fraction, I have x minus 3 as a factor and 5 as a factor. So 5 is monomial. I'm going to put it in front of the binomial. So we're picking up where we left off in last class. Solving rational equations. Now, let's get rid of those parentheses. On the left side, do I have any parentheses to get rid of? No, so for now, I'm just going to bring that down. Nothing to do on the left side right now. Bring down your equal sign. And then I can distribute to get rid of the parentheses. So 3 times x is 3x. 3 times negative 4 is negative 12. Positive 5 times x is positive 5x. 5 times negative 3 is negative 15. Any questions about that? Now, what do you think I'm going to do? Combine like terms. On the left side, do I have any like terms to combine? No. Do I on the right side? Yeah, so before I start moving stuff from one side of the equal sign to the other, if I have like terms on one side, I need to do that first. So on the left, no like terms to combine. I'm just going to bring it down. On the right, what's the highest degree on the right? The degree. X to the first power, right? So 3x, that's called a linear, is linear. And 5x is linear. As long as they have the same variable and the same degree, they're like terms. They're both positive. What do I get when I combine them? 8x, and it's positive, right? Well, negative 12 is a constant. It has 0 degrees. Negative 15 is a constant. It has 0 degrees. So be careful with your signs. If you don't know, use your calculator. We're where we left off last class on the notes. We're just picked up there. So first of all, there are two negatives. We're adding them together. Are we going to get a negative or a positive? Negative. We're not multiplying them. We're adding them together. So there's going to be negative, right? And then we add the absolute value. What is 12 plus 15? 27. So that should be negative 27. Now here's the part where kids don't know what to do. If I just had linear terms and constants, then I could solve for x. Or if I just had a quadratic term and a constant, then I could solve for x. But I've got quadratic terms and linear terms, and neither of those are going to cancel out, right? So I can't just like move everything to one side and solve for x. If you've got a quadratic term and a linear term, if nothing's going to cancel, you just can't do that. So what you got to do when that's the case, and this happened last class too, we're going to get everything on one side of the equal sign and 0 on the other, because we're going to have a quadratic that we have to solve. Okay, cool beans. So since x squared, that's the term with the highest degree, it's going to be my leading term when in standard form. It's already positive. I don't want it to become negative. So I want it to stay on the left side. So I'll bring the 8x over to the left and the negative 27 over to the left. Okay. And I can do this in one step or two. I'm going to do it in 2 steps. So I'm going to add 27. So on the right side, that'll cancel. And I'm left with x squared. What's negative 20 plus 27? What? Not minus. Plus 7 equals 8x. Now what? I'm going to subtract 8x. So on the right side, 8x minus 8x is 0. On the left side, do I have any like terms? No. So don't just write it in the order you see it. A lot of kids will say, oh, it's x squared plus 7 minus 8x. Well, is that standard form? No, and you're going to want it to be in standard form. So what term would I write first? Very good. Now the directions told me to solve. I haven't solved yet, right? Again, if I was missing this linear term, I could just put 7 on the other side, solve for x by taking the square root of both sides. If I was missing this quadratic term, I could solve for x. But when I have a quadratic term and a linear term, I have to do more work. So we have a quadratic here. I can either, to solve a quadratic, factoring. Does factoring always work? No. Quadratic formula always works. And or completing the square. That always works, right? Well, let's see if we can factor. So if I could factor that, is there a GCF? What's A? What's B? What's C? if we could factor, we would need two numbers that multiply together to give us A times C, which in this case, that's a positive 7. And then add together to give us B, which is negative 8. Negative 1, negative 7. Let's see. Negative 1 times negative 7 is positive 7. Negative 1 plus negative 7 is negative 8. That works, right? Are we going to need to divide and slide? No. So my factors, we're going to have an x minus 1 and an x minus 7. I have factored, but have I solved? No, I haven't. Once I factor, what do I do to solve? Say it again. Yeah, I got to set each factor equal to 0. So x minus 1 equals 0, and x minus 7 equals 0. So a lot of you, if you get to this point and you tell me your solutions are negative 1 and negative 7, I am going to scream. Is that your solutions? No, what are your solutions? 1 and 7, because when you solve for x, it changes that sign. So we're saying they're the solutions, but could they be extraneous? They could be. We got to check, right? Remember that part? You got to look for your restrictions or your excluded values. So remember to do that. Go back up to your problem from where the denominator was factored. And you're looking for values of x that if you plugged it into the denominator, you would get a 0. Okay, because you can't have 0 in the denominator. So let's go up to this step here. If I'm talking about x minus 3, what would x have to be to give me a 0 there? 3. So 3 is a restriction. When I'm talking about x minus 4, what would x have to be to give me a 0? 4, because 4 minus 4 is 0, right? So x can't be 3 or 4, and these two would be the same, 3 and 4. X cannot equal 3 or 4. Did either of my answers equal 3 or 4? No. So my answers are good. Remember, say if I got a 3, well, mathematically, x did equal 3. But when I substituted it back into the problem, 3 gives me 0 in the denominator. That can't happen. So that's when you would have an extraneous solution. Mathematically, it's correct, but it gives you a 0 in the denominator, and you can't have that. So that's what extraneous comes from. So it'd be a shame to get all this right and get one of your solutions to be a restriction or excluded value, and you didn't check it and you got it wrong. Would I count off all the points? Of course not, especially if you did all this math right. But if it was a multiple choice test, yeah, because multiple choice, right? It's right or wrong. Any questions on that one? All right, example 6. Well, we're probably going to have some class time today. I'm going to do a lot of problems that y'all are going to like do practice on, like maybe, I don't know, even use our desks. I don't know though, because probably a lot to fit on our desk. And then have time to start the practice problems. That's my goal, because we won't be doing notes the whole time. Yes. What? Oh, yes, by EJ. EJ, put that phone up. He was wondering where the pencil sharpener was. All right, we're going to solve, and some of these are way easier than other ones. They can get very complicated. The one that you just had, that's the, oops, I didn't mean 5x. I meant 5 divided by x. This is way easier than the last one. Doesn't even just look like easier. Does it? Oh, this is way easier, way less work to do. So first of all, let's look at our denominators. I have 4x, and remember, this is technically a 1, right? If it's just a monomial, you don't need to factor it. So 4, yeah, 4 can be factored, but it's 2 times 2. We don't need to write that for a monomial. X, any factoring to be done? 1, any factoring to be done? Nope, but I want to get rid of these fractions. I want to clear the fractions. So if we figure out what the least common denominator is, and we multiply each fraction by the least common denominator, we can clear the fractions. So I've got 2 denominators, 4 and x. What's the least common denominator? If I multiply everything by 1, so I multiply x force by 1, is that 4 going to cancel? If I multiply negative 5x by 1, is that x going to cancel? I need everything to cancel. Think about that when you're thinking about your LCD. What would I need to make this 4 cancel? A 4. What would I need to make this x cancel? An x. Just 4x. Just 4x. They're not binomials, okay? They're not binomials, just monomials. So my least common denominator is just going to be a monomial. So I'm going to rewrite this, giving myself some space. And I'm going to multiply each term by the least common denominator, which is 4x. So remember, when you are reducing a monomial with a monomial, you can just reduce part of it. It's different than a binomial. Binomials all or nothing, but these are a bunch of monomials. So I can, if I want to, I could do 4 times x first, and then divide it by 4 and reduce, or I can reduce before I multiply, which is, I think, is easier. So would anything cancel in my first fraction? The 4s would. Not the x's, they're both in the numerator. They don't cancel each other out. You gotta have 1 in the numerator, 1 in the denominator to cancel. Anything cancel in my second fraction? X. How about in the third fraction? It's just a 1, there's nothing to cancel, right? So let's write what we have left. We have in the first fraction, x, 2 x's. That's not 2x though, we don't add them together. Whatever's left, you multiply. So that's going to be x times x from my first fraction, minus, what am I multiplying from the second fraction? 4 times 5 equals, what am I multiplying? 4x times 2, right? It's not squared. 4x times 2 is 8x. So now let's multiply. What's x times x? X squared. Negative 4 times 5. Negative 20. Bring down your equal sign. 4x times 2. 8x. Can I just solve for x by moving everything on one side and solving for x, or is it going to be more complicated? More complicated because you have a quadratic term and a linear term. You're missing either one of those, we could easily just solve for x. But if you have them both, you got a quadratic that you're going to have to either factor quadratic formula or completing the square to solve. Okay, so I need to get that 8x over to the left. How will I do that? Subtract it, very good. So on the right side, everything cancels. On the left side, are any of those like terms? No. So they're all, we can't combine any of them. We need to put it in standard form. What term would come first? x squared, and it's negative, and then negative 20. So to solve this, I'm going to try to factor, if I can. Is there a greatest common factor? No. What is A? What is B? What is C? So we need two numbers that multiply together to give us A times C, which in this case, A times C is negative 20. And then add together to give me B, which is negative 8. All right, let's see. Negative 10 times positive 2 does multiply to give me negative 20. And negative 10 plus 2 does add to give me negative 8. Perfect. And will I need to divide and slide? No, I can, but if you divide by 1, it doesn't change anything, right? So what are my factors? X minus 10 and x plus 2. Very good. So I have factored, but have I solved? No. So we know once we're factored, set each factor equal to 0. Solve for x. And that will be our solutions. If they're not a restriction, you only get restrictions from fractions that have a variable in the denominator. If there's no denominator, or if there's only numbers in the denominator, you won't have a restriction. So am I going to have any restrictions? What? 0. Because x force, I won't get a restriction from there. There's no variable, right? So I can't have a 0 in the denominator. And the second fraction, the only thing x could be to give me 0 in the denominator is 0. And then this one, there's no variable in the denominator. So my only restriction, what x cannot equal is 0, and neither of my answers were 0. So I'm good. Totes, right? So easy. Ever? Same thing over and over and over? Yeah, I don't know about that. Let's do one more together, and then we're going to practice on our own. Not like the practice problems that I'm going to give you at the end of the class, but practice. No, that's a quiz. Practice at the end that you do on your own that I don't grade, I call those practice problems. But we're going to do some practice in class together as well, like where I walk around and see how you're doing. So we have 4 divided by m squared minus m equals 1 divided by m squared minus m plus 3 divided by m. Before we determine our LCD, let's make sure all denominators are factored. Can I factor m any further? No. How about m squared minus m? Is that completely factored? I know I at least can take out a GCF, am I right? Because they're both 2 terms and both terms have an m. So let's start there. My greatest common factor is an m. So it's a factor, it does not go away. If I divide both terms by m, what's m squared divided by m? M. Think about it as I had 2 m's, I took 1 out, only have 1 left. minus, what's m divided by m? The number 1. If I distributed m times m is m squared, m times negative 1 is negative m. If I put an m here, m times negative m would be negative m squared. That's not the same. And so this would also factor to the same thing, right? Because they're the same. And you'd also need an m because this m would not be included. Yeah. But if you just said, if you said your GCF, your least common denominator was m and m squared minus m, you could do that. You just have more reducing in the end. Okay. So I'm going to rewrite this with this as the denominator for these two fractions. So 4 divided by m times m minus 1 equals, give myself some room, 1 divided by m times m minus 1, put plus, give myself some room, 3 divided by m. What's my least common denominator? So if I multiply all these by m, everything's going to cancel. Just m minus 1? An m and m minus 1. Because I said, a lot of kids say it's just m minus 1 because there's an m and m minus 1. But if I just say m minus 1, and I multiply this first fraction by m minus 1, is this monomial of m going to cancel? No, if I just do m minus 1, only the m minus 1s cancel. So my LCD is an m and m minus 1. So I'm going to multiply each fraction by m times m minus 1. Right? You see how it can't just be m minus 1? M minus 1 and m do not cancel each other out. So my first fraction, what's going to cancel? The m and the m minus 1. My second fraction, what's going to cancel? The m and m minus 1. My third fraction, what's going to cancel? Just the m. Go to each fraction, whatever's left will be multiplied together, but I'll write it down first, then I'll multiply it. So my first fraction, what's left? 4. Then I bring down the equal sign. My second fraction, what's left? 1. Bring down your plus sign. Third fraction, what's left? Yeah, don't forget that 3. And since it's a monomial, I'll put it in front of the binomial. What would I do now? Distribute, right? Everything else I'll bring down. So bring down the 4, bring down the equal, bring down the 1. 3 times m is 3m. 3 times negative 1 is negative 3. Now, does this one have quadratic terms and linear terms? No, so it's going to be easier to solve. We're not going to have to do factoring or quadratic formula or completing the square. We can just solve it. But before we do, don't I have like terms on the right side? Okay, so let's combine them. 4 equals, what is 1 minus 3? Negative 2, bring down your 3m. Now what? I want to solve for m. I could, but I'm going to cause myself to have an extra step. I want to get m by itself, so I don't want to bring this over here. I don't want to put more stuff with m. I want to move stuff. I mean, I can, but I'm causing an extra step. I want to move things away from m. Add 2 to both sides. Six equals 3m divided by what? 3. And m equals 2. Well, what are my restrictions? M cannot equal, yes, a 0 and what else? One. A 0 from that monomial by itself, and then a 1 because of M minus 1. Is my answer a restriction? Nope, so we're good to go. So that one, and the end was less work because you didn't have a quadratic term and a linear term, right? Now, what if there's no factoring to do in the denominator? Is there always going to be able to factor the denominator before finding the LCD? No, if you look back at example 1, we didn't have to factor anything to start. There was nothing to be factored. So if that's the case, great. Then determine your LCD and multiply each term by the LCD. So I want y'all to do this one on your paper. I'm going to come around and be looking at your paper. So we have 4 equals x divided by x minus 4 minus x minus 2 divided by x minus 4. Yep. Well, can it be factored? Nope. So then you can just go ahead and determine your LCD. You just try that second fraction on the right side. You don't see sign both times. So you need to put a parentheses there. Distribute that negative to both times on the right. Yeah, and the first time, we're down the minus sign, and we're down to minus two. That is negative two x minus two is greater than four. All right, can either of my denominators be factored? No, okay. What's my least common denominator? X minus 4, okay? So I multiply every term by the x minus 4. So I'm gonna multiply the 4 by x minus 4. Is anything gonna cancel there? When anything cancel? No, there's no fraction, right? I'm going to multiply the second fraction by x minus 4. Bring down your minus signs. I'm going to multiply the third fraction by x minus 4. Okay? So nothing cancels over here. There wasn't a fraction. This, what cancels in my second fraction? X minus 4. What cancels in my third fraction? X minus 4. Go back from each fraction and write what's left. If it's more than one factor, you have to multiply them together. If it's just one factor, you just bring it down. So on the left side, there was more than one factor. So I've got to multiply them together. I'm going to put that monomial first, because usually that's how you see it. So I'm going to have to do 4 times x minus 4, right? Bring down your equal sign. The only thing left in the second fraction is just x. There's nothing to multiply it by. Bring down your minus sign. Your second term, you only have one factor, but there's 2 terms. I only saw one person put a parentheses here. And the reason this is important is because you're not just subtracting the first term, you're subtracting both terms. If I subtract and there's 2 terms there, I got to distribute that negative. So be super careful about that. Okay. Anybody have a question at this point? Asia, phone, backpack, put your backpack on the floor. So I need to distribute to get rid of my parentheses. 4 times x is 4x. 4 times negative 4, negative 16. Bring down your equal sign, keep everything lined up. X, there was no multiplying. And then I've got to distribute that negative. So negative times positive x is negative x. Negative times negative 2 is positive 2. Anybody confused by that? On the left side, do I have any like terms to combine? Any left like terms? No. On the right side, do I have any like terms to combine? Yeah. So what's x minus x? 0. 0 plus 2 is 2. So all I have left on the left side is a 2. Do I have a quadratic term and a linear term? No. So can I solve this easily, or am I going to have to do like factoring or quadratic formula or completing a square? I can solve it easy, right? So what do I do next? Add 16 to both sides. So I have 4x equals 18. Then what? Divide by 4. X equals this 18, this 4 divided into 18 evenly. Not evenly, right? So 18 fourths, but I can reduce it. What divides into 18 and 4 evenly? 2. 2 goes into 18 9 times. 2 goes into 4 2 times. All right, anybody have a question? Like I said, they're all different, all different. So different things are going to happen. The more you do, the more you're supposed to, easier it's going to be. Try this one. 2 divided by b minus 4 plus 1 divided by b squared minus 6b, I shouldn't have used the b, plus 8 equals 3 divided by b minus 2. I can't hear you. Why did I use b? Because that's what the problem on the paper I'm looking at used. But this is 6b. Make sure you know your b's are b's and your sixes are sixes. And I'm going to give you a little head start, and then I'm going to come look. What time's the Summerlin bell ring? 7? Because I got to put the practice problems up too. Who all leaves at Summerlin bell? All right, you Summerlin bell people, you might, I'm going to put the practice problems up so you can take a picture real quick or write it down, up to you, and then I'll come do the problem. If you're not Summerlin though, keep on working on this problem. Yeah, hold on. So these are going to be the practice problems that you do to make sure you understand it. We have a quiz next class, right? I'm putting that up so Summerlin people can take a picture real quick. If you're not leaving at Summerlin bell, continue working the problem, and then I'm going to go over it. I'll put it back up, but y'all probably know about it. You can. And the problem y'all are working on are all of your denominators factored. No, this one can be factored, right? Do I need to show you the factoring for that? I'm kind of running low on time. Would y'all agree that the factors are what? You tell me. I don't need those kind of answers. B minus 4 and B minus 2 are the factors. All right, well, what's the least common denominator? B minus 4 and B minus 2. So if I multiply every fraction after 3 for every term by B minus 4 and B minus 2, and then I'm going to come back and cancel. So my B minus 4's cancel in the first fraction. In the second one, B minus 4's cancel, B minus 2's cancel. And the last one, only the B minus 2. So from each of these terms, come write what's left. If you have more than one factor in the same term, you're going to multiply them together. So in my first term, I've got a B minus 2 and a 2, right? So I'm going to have to multiply them together. I'll come back and do it in a minute. Then it says to add. All I have left in the second fraction is just the 1. If you add 1, that changes the number. So you got to put your plus 1. Then bring down your equal. Over here, I've got a B minus 4 and a 3. So I've got to multiply them together. Everybody else, do not add up. Everybody cool with that? Now what do I do? Distribute. So I've got 2b minus 4 plus 1 equals 3b minus 12. Would y'all agree? Do I have any like terms on the left side that I could combine? Yeah. Negative 4 and positive 1 make what? What's negative 4 plus 1? Negative 3. Bring down your equal. On the right side, any like terms to combine? No. Now, do I have quadratic terms and linear terms left? I don't have any quadratics, right? Only linear and constants. Well, that's easy to solve for. I can just solve for x. I'm not going to have to do factoring or anything like that. So I need to get my b's on one side. What could I do? I'd have to subtract it, right? It's 2b plus 2b is 4b. I want to turn into a 0. 2b minus 2b is 0. So on the left side, bring down your -3. Bring down your equal sign. What's 3b minus 2b? 1b, or just b. So b minus 12. Now what? Add 12. What's -3 plus 12? 9 equals b. What were my restrictions? What can be not equal? 6. 4 and 2. So is my restriction extraneous, or is my answer extraneous? No, it's good to go. All right, here are the practice problems. Again, I'm not grading these, but do y'all think you might need practice before the quiz next class? Make sure you know how to do it and what your questions are. So you can take a picture or you can write them down. I will post them on Schoology. Lately, I have been having issues uploading stuff. Not from Schoology, but when I take the picture, I don't know, it's a lot to explain, but I will do my best to get it uploaded to Schoology before I leave today, but lately I've been having issues with it. You might need to go back and rewatch the videos. If you're struggling, and don't just watch them, take notes on it.